Hello, everybody. I am showing 2 o'clock here, so let's go ahead and get ready. Um, if you have not attended one of these, hello, my name is Whitney Turner, and I'm a faculty member in the Johnson County Community College's Mathematics Department. In addition, I am able to I'm able to serve as the co-chair of the Kansas Pathways Task Force. As many of you know, we are working across Kansas to implement math pathways, as well as co-requisite support and our multiple measures across the state. Since there's so many of us here today, please make sure to mute those computers. As well as for questions today, we are going to go ahead and use the raise hand function so that our speaker can see and answer any questions that you have. And let's go ahead and welcome Dr. Kathleen Alme from Alme Education. We are very lucky to have her, and I'm going to go ahead and turn it over to you.
Oh, have to unmute. Okay, so first off, can you guys hear me? Yes. Okay, so I don't know if there's a lag. I am at a Matic, so I'm curious if anybody is at a Matic right now. You can see I'm in a hotel room. Put it in the chat. I'm curious because I talked to some people this morning that were going to possibly try to pop in, and if you did, yay for you. And if they didn't, I understand because I did a co-requisite talk this morning. This will be a little bit different. We're going to go into more things. I am hoping that the hotel Wi-Fi, I upgraded the package. I hope it will be good. If I start to get a lot of a lag, and usually I can tell if it does, but if you can tell and I'm not seeing it, let me know in the chat, and then I will just get rid of my video, and maybe that will help with some of the bandwidth. Okay, so first thing is I need to get to know y'all. There's some names I recognize, but a lot that I don't know. And so before I introduce myself, I want to know who you are. So could you go into the chat, please? And I would love for you to put what role you have at what institution you're at. So I'm a vice president at such and such. I'm math faculty at such and such college. Go ahead and put what you do and where you do this for a living. Awesome to see Connie's here. Okay. You can absolutely turn your camera on. Anybody who wants to join me, I'm be happy to see you. Academic affairs, that's great. Vice president, math faculty. All right. Math physics at Coffeyville. Fantastic. Oh my gosh, this is just great. All right. Hello again. Hi, Bethany. Let's see. Fantastic. Okay. Do we have anybody here from Dodge City? I don't know if I've seen them yet. Do we have anybody here from Pratt? I'm curious.
I am on at Dodge City. Kathy, Stephanie.
Yay, hi, Stephanie. All right. Fantastic. Okay. All right, I'm just looking through because I'm curious. Ooh, I saw Emporia State. That's always exciting to me. So those of you that know me, you have to bear with my boring story really quick. So my family is from Kansas. I grew up, well, I'm not right now, I'm staying in Atlanta in a hotel room, but I grew up in Illinois. I'm the only person in my family before my children that was born in Illinois. All the rest of my family is from Kansas. And my dad grew up in Emporia, and my mom grew up in Chanute. They have family in Miami, Oklahoma, as we were always told. It is not Miami. So those of you that are in southeastern Kansas, you know that's how it's pronounced. But I spent my childhood going to Kansas regularly. And my parents both went to, and my brother and my great aunt, like we had everybody and their brother went to Emporia State University back when it was called Kansas State Teachers College. So my dad was a math professor. My mom was a kindergarten teacher. So just have a very fond place in my heart for Kansas, to say the least. All right. I love it. Okay, now I want to hear from you guys. What is it that you want to come away with? You're giving 2 hours of your time on a Friday afternoon. I'm so appreciative of it. I want your time to be well spent. I want you to be like, okay, that was worth it. That that I did this because, you always have other choices. And so I want to hear in the chat, what is something, either a question you have or something you want to take away from today, so that I can make sure I know what your goals are, so I'm addressing them. So I'll wait. Let's get some comments in. So question you have, or what is something you hope to learn about today? How to approach a co-rec course. Awesome. Okay. Fantastic. Let's keep them coming. I promise there will be content. Fear not, we will get there. But I like to just get to know my audience first and what your needs are. So surely we have more thoughts on co-requisites. All right, scheduling. Let's keep going. Online. Ooh, that's a whole thing. That's another interesting area. And it can be done. I'm not saying it can't be done. I don't want to sound ominous with that, but it's a challenge, just like teaching on anything online is. Anything else? Come on. Okay, how to, yes. Oh, I have a particular fondness for the college algebra pathway. Yes, awesome. How to reach our lower learners. Yes, what can we do if they're not successful? Which is better, front-loaded or just in time, or a combination? Carol, that's awesome. We are going to directly answer that. College algebra pathway. Let's see. Okay. Anything else? If you think of it, go ahead and throw it in the chat. I'm just curious, so I have a sense of, what your goals are and what would make this useful to you. That's what's really important to me. Okay. Okay, Kendall. Good questions. Okay, so to my best of my ability, I'm going to try to make sure we answer this. It inevitably, because I have not written every single one of these down, I may forget something. So you are absolutely welcome to put something in the chat. Now, I'm very much a easily distracted person, so I'm going to try to not look at the chat until like certain times so that I don't get off course. But if you have a question or you really want to talk about something that I'm bringing up, just raise your hand, and then we'll, we can talk through it. If there's something that it's like if you put this in here and you were really, really concerned and I skipped it by mistake, because I want to answer all of these, and I think I can pretty confidently, I can answer these. Remind me, or just say, hey, you still haven't answered my question, and we will go through it. Which pathway do you put undecided students into? All right, I'm just going to go ahead and answer that. We need to be putting undecided students unless they absolutely know, like, let's say they're decided on STEM, but they don't know, like they're still trying to figure out which piece of it. That's kind of an exception, but in general, if they are undecided, we want to put them in a non-STEM course, something like a modern college math, liberal arts math, quantitative reasoning, statistics, something like that. We'll talk more why and why that matters and all of it, but that's one that you can just take away right now. That is really useful. And if you're wondering, why would you do that? Because one of the most important things, and take it from someone who finished their dissertation earlier this year on college algebra co-requisites. I've read so much literature on co-requisites, it's not even funny. And my theoretical framework for my dissertation was this holistic framework of success at community colleges. And one of the things that was built on was the idea of momentum and how important it is that we build momentum in students. And what we want is students to take math in their first year, but even better would be their first semester. And we need them to get a legitimate win. So not like give everybody an A and make them feel good, but they actually, we hope that they can have a successful experience and pass. That does mean something. And it does really help them to, to further where they're going. Now, if they need college algebra for something they're doing for their program, great. Or wherever they're transferring to, that's not an issue. Or if they're at a 4-year and that's what's required. But if they really don't know, and actually one of the colleges that I've worked with, Pratt Community College, their vice president, Monette, I like what she said when we were working together. It was, we're going to advise them for right now, not necessarily all the possibilities that can happen. And we're going to make sure that they can change their mind, because they might, and that's not unheard of, but we're going to advise for right now and put them in the course that makes sense. And hopefully it be a successful experience. All right, so let me share slides, and I'll move that out of the way. Let me see. I'm going to slideshow. I will share. Okay, so can you all see slides?
Yes.
Thank you. I was gonna say, I can't even get my chat up. Here it is. Here's my chat. Yay. Okay, so because I like to keep tabs on what people have questions on. Okay, I brought this little portable extra monitor with me, and I'm very glad I did now. I'm like the Kathy who packed was thinking. Okay, so let's see. All right, have been additional interventions for lower level students that will have an impact on students' learning. Okay. All right, so my goal today, we're going to hit as many things as we can related to co-requisites. We will not get through everything. There is a lot that's going on with making co-requisites work, but my goal is to get you lots of really tangible information that you can use today that in a lot of different levels. We're going to look at some things that are more at like the course level, which are some of the questions you've had. We're going to look at things at the classroom level so that you really get a variety of good information. Okay, and the goal is that we are coming up with, so regardless if you're faculty or administration, or your staff, or you have another role at your campus, we want math co-requisites to work for everyone that is impacted by them. So that means faculty, but also the others at the college, and especially students. That's really important. Okay, so who am I? Some of you I know, but a lot I don't. So it's kind of exciting again, getting to meet a lot of new folks, which I always like to do. Just changing this so I can see a few more faces. Always like to, again, feel free to turn your camera on. Don't be like your students, resist. Oh, get some critters in the background. I like that. Okay. All right, so I don't give this to be like, yay, look at me. I give you this background because what I'm always thinking is when someone is giving me time to come to a presentation, a workshop, whatever, they are wondering, and it's a very reasonable thing to be wondering, why should I even listen to this person? Like, what do they even know? They have anything to even talk about that's going to benefit me? So that's what we're going to start with, just so that you get a sense of what my background is. So I'm in Illinois, Northern Illinois, again, not this minute, but that's where I live. If anybody knows where Rockford, Illinois is, which probably most people don't, but it's about an hour and a half from Chicago. So I've been in higher education the vast majority of my career. I did start off as a high school teacher. I always told my college students I taught high school, and that's why I teach college. That's a special skill set that it takes. Oh, Carol, those are Rockford is. Yes. All right. I like that. It's 150,000. It's not teeny tiny, but it's just not necessarily people have heard of it. Okay. So 25 years teaching math, over 20 in higher education, most of them at a college. I was tenured at a community college in Northern Illinois. Okay. So reform work for math has been something I have been, as my husband would say, obsessed with forever. And I really got into it heavily in 2007. Started at my college. I've done a ton of stuff in Illinois, and I've also done lots of work nationally. Basically on not what was ever the fad. I've never been about fads. I've been about what could we do to make the experience better for students and for other people, including like faculty and all those at the college that are impacted by these math requirements. It's changed over the years, and I bet a bunch of you are familiar with this. You know, we've had emporiums, and we've had like the self-paced model. We've had modularization. We've had pathways and more relevant content. We've had co-requisites. There's all these different things. The main thing I want you to know about this is it's not like we're saying, okay, now we have landed on the perfect thing that is going to work and all this other stuff didn't work. The reality is all of these different approaches that we've used, including standalone dev ed, have worked for certain students, but none of them have worked for everyone. And some of them have worked better for some students than others. So one thing I'm a big proponent of, and you'll understand why in a second when I just explain a little bit more, is I believe that colleges, that all of you are, your colleges are unique, and you have to come up with the magic combination of these different interventions that work for your students within whatever guidelines that you have. So you have guidelines from the state of Kansas. There's been lots of work on that. In Illinois, we have guidelines, and it's like, it doesn't matter what your guidelines are or laws or whatever it is, we have to work within them, but we have to still find unique solutions. So like saying we're doing co-requisites is like saying, I'm going to try to get healthy. Like there's a lot of ways to do that. So I don't want you to think, well, it's like, there's just one way to do co-requisites. There isn't, there's a lot. And some are more effective than others. Finished my doctorate this summer. My dissertation was on college algebra co-reqs. Why? Because I'm fascinated by co-requisites. I used to hate them. I used to think they were awful. And I thought it was crazy that anybody, so I'm very much an open book. And those of you that don't know me will learn that very quickly. So I'm curious born in Aurora. Very cool, Sandy. Anybody in the chat? I want to know the truth, or you can raise your hand or you can do a thumbs up. Has anybody here ever been skeptical of co-requisites working? Oh, get a little bit of that. Yes. Just curious. And you're not alone. I absolutely was like, this is out. So I'm just going to, let's say the quiet part out loud. I'm like I thought this is dumb. This is not going to work. I don't see how it's possible it could work. And I kept thinking, because like my favorite class to teach is elementary stats. Love it. Could teach it for the rest of my life and be very, very, very happy. And I could never imagine students sitting in my beginning algebra class being in my stats class and being successful. I couldn't see it. I'm like, they can barely graph a line. I don't know how that could be, but I was wrong. And I have changed my mind. And I will tell you, I didn't initially change my mind because of the copious amounts of data. I wish I could say I did, but that's not how humans make decisions. We make decisions usually out of emotion, even though we say that we are data driven and everything. Humans make decisions out of emotion. And I will honestly say the place where my mind was changed with this, when I had a friend who was at another college who was required to do this at scale. And he's like, Kathy, this could actually work. And I'm like, but how? And he went through and explained to me, and I was like, oh, so we're not going to teach all of beginning and intermediate algebra in like 2 credit hours and then attach that to stats. He's like, no, that's not what we're going to do. There are ways to actually make this work, and the students are passing. And once I could actually hear it from a peer, I was like, okay, tell me more. And I did change my mind over time. And yes, the data is very conclusive. There's a lot of students that can get through a co-req. I'll tell you one of the biggest things that we know about co-reqs, here's another thing I was wrong about. I used to think co-reqs were only for bubble students, the students that are really, really close to placing in a college level, but not anybody else. That's actually not true. That's something we found from data, that there's a lot of students that can be served by co-requisites far more than we thought. Now, there are some students that can't. I'm not going to lie and say that everybody can pass a co-req. They can't. Just like we don't have, I don't know, those of you who are teaching calculus, do you have a 100% pass rate in calculus? Maybe you do, but there's a lot of people that don't. There's always going to have subjects that we have courses and that students don't necessarily pass. And if you're wondering, oh my God, is she ever going to get through this first slide? I promise I am. Fear not. But I just thought of that and I wanted to mention it. I will keep going. I had a point with that, but squirrel brain, it already has taken off to another level. Okay, let's see. Data standalone is ineffective for most students. Okay. So let's continue on. I will try to focus and get myself back around where I'm supposed to be. I had a point with that, but it's already lost its trail. Okay. They absolutely can work. That's what I was going to tell you. There are a small population of students that it's still too much for. Every state does it differently in terms of how it addresses that population of extremely high need learners. They exist. Let's be real and not act like they don't exist, because they do. However, they are not in the grand percentage that we might think they are. They're not. And there are ways to serve them, which may be adult basic ed, it might be a bridge program, there's all kinds of ways, it might be embedded tutors. There are a variety of ways to actually support these students, even though they have much higher needs. And it isn't necessarily, well, if we don't have a standalone beginning algebra class, they're doomed. That is not the case. Okay. And in a second, I will tell you why I can say that with some confidence. Okay. So I did write a developmental textbook. I'm not listing the name or anything about it because I'm not selling you a textbook. I mention that because I want you to know the depth of which I understand and believe in the concept of developmental education. However, with that in mind, I don't believe in the concept. And I actually said this to my publisher yesterday because I saw my publisher and I'm going to be going to a dinner thing tonight with them. I don't advocate for my book with schools because it's for a standalone developmental class. And that course is not needed. It was a course that was built for students that were going to go into like modern college math or stats. And students can pass those courses with a good co-rec. The vast majority of students can be successful in those. So what I learned is the concepts that we did that, or the techniques that we use to teach developmental math still matter. Those skill sets are still necessary. What is different is where we are applying them, when and for whom. So it doesn't mean that those ideas, it doesn't mean that all of a sudden the students are prepared. No, they're not. They never were either. But that's not what we're saying. We're saying that we can serve our students. I can tell I'm tired. My brain just it's like fitzing out. I'm going to try to focus. All right. So let's keep going. I've done state level implementation of math legislation. The reason I'm mentioning this to you is because I'm used to working with lots of groups, including states, and dealing with when you have a rule that you have to put into place. Our legislation in Illinois that I was in charge of the implementation for was infected all 700 high schools, all 48 community colleges, and all of our public universities, which I believe we have 12. So it was a great learning experience. And that led me to 5.5 years ago, I started ALMI Education, and that's what I run full time. Been doing that. And we are now supporting nearly 60 colleges. We started off math. That's my background. It's what I know inside and out and how to improve it. But slowly, as we're working with schools, they're like, oh, do you know anything about English? And then I brought on English faculty to help with that piece. And then now we've moved into biology and chemistry, and they are actually doing co-requisites as well. The concept does work, co-requisites. When done right, it's not going to be a savior, but what we're doing, the traditional method, isn't a savior either. It's not necessarily doing everything we want. All right, so let's talk about what is the point. I don't know if that's showing up on your screen, but I'll get rid of that. What is the point of a co-requisite course? So this is one thing I really want to establish. This is my definition of it. There's other ones, but what I believe co-requisites are meant to do are to provide flexible yet intentional support so that a student successfully completes a college level course. And that's it. It isn't about hitting a bunch of algebra skills just in case. It's not about anything other than what does the student need to be successful in the college level course. So what that means is when I'm working with, so as I mentioned, I work with a lot of states and schools all over the country that are implementing laws, co-requisites, math pathways, multiple measures placement. That's all I deal with day in and day out. And we're only getting more colleges that we're working with. Boy, I'm going to tell, my brain is just like tired. I can tell that. So the idea is not, I know where it's going with that. The idea is not there's a couple of states that I work with where it's basically they're just joining a developmental class with a college level class and keeping all the credits for each. There are states out there that have 5+5 co-requisites, 5 credit hour co-requisite, 5 credit hour college level course. That's not what we're talking about. That won't work. And when they're dissatisfied with it, I'm not surprised. That doesn't work for anybody. Okay. What we have to do is instead of thinking, what's all the stuff that we did before and how do we smush it together and still get through it? No, you think of the new goal. What does a student need to be successful in the college level course? That's going to differ. And I'm going to give you some tangible examples in just a second. That's going to differ if we're talking about a student in statistics compared to a student in college algebra. But there are ways to support them. So we're going to get into a lot of ideas, very tangible things that you can actually take with you. And there's things, I mean, potentially that you could implement next week. Okay, so I want to caution one thing on this screen. I am not saying that doing homework, having tutoring, skill development, I am not saying that you're not going to do that in a co-requisite. What I am saying is that cannot be the only thing you do. And some co-requisites, through no fault of faculty, because here's the reality. Faculty, and it's funny, my session this morning that I did at Amatic was called No More Winging It, best practices for co-requisite instruction. The reality is there are some guides about co-requisites, but the bulk of the literature is about efficacy and more logistical things. How many credit hours? Is it the same instructor? Is it a different instructor? All of that stuff all matters. We need to know all of those things. However, that isn't enough. We need to know, like, what are we actually supposed to do in the classroom? There's been some, I'm not going to say there's none, but there hasn't been enough, and definitely not in the literature, in terms of real tangible advice to faculty, like how do you actually run a co-requisite class? Like, what do you actually do with that time? And whenever I've asked faculty, and I've been asking faculty for over 10 years, tell me what your co-requisite looks like. The answer I always get is, well, it depends. We do a little this, we do a little of that. And that isn't bad. I'm not saying that that's wrong. I'm saying a lot of us just feel like we're trying to figure it out as we go. We're trying to build the ship and fly it, or build the plane and fly it at the same time. Because there isn't a lot of like, this is how we teach co-requisites. We know how to teach college level, we know how to teach developmental, but this is a different beast. This is something different. So what you don't want to have, and this is not a judgment of you, because if you're thinking, well, that's what we do right now, that's okay. I'm just going to give you some ideas to think about and what you can do to adjust. And if they're wondering like, well, I'm not seeing this amazingness that everybody says co-requisite has. It could be just as simple as one of these things that I'm talking about that you may not know that's playing into it. So you can't just have it as, okay, what questions do you have today? And it's just like, it feels like a recitation, like when we were back and we were in graduate school. It can't just be the skill development and breaking skills down. So it's not just going to be the things that we did in beginning algebra or pre-algebra or intermediate, just at the same time as taking a college level class. That isn't enough on its own. Necessary, but not sufficient, math folks. It should not feel like a concurrent course with double the assignments. If it does, your student is constantly going to be trying to figure out, where do I split my energy, my time, my focus? Should I be working on these assignments or these assignments? You can have quizzes, you can have homework, I'm not saying you can't have those things. You don't need tests in the co-req, but it should not feel like the student is just in a second math class. It should feel like it is an additional piece to their math class to help them be successful. They should understand that that's what the time is for. It is absolutely not meant to be more time to teach new content. So the place where this really becomes an issue is some schools have like a separate co-requisite time and class period. Some schools have where it's just like extra time that's built in and spread throughout the week. It is very tempting, and I will say I'm the first one to succumb to this temptation, that if I have extra time, I'm going to be like, well, we didn't get to all the examples I wanted to yesterday. That's support, right? That's support. And I'll just do a few more examples. Or we didn't get to this, so we'll just do that during the co-req time. It's fine. It's one time. That's what we have to resist. That's one of the main things I want you to resist, that urge to do that. Because it's not about teaching more and new during the co-requisite time. That time is reserved for something else. So we'll look at that in a second. And it absolutely should not be disconnected from the college level course. The student should be able to see a direct relationship between the things you're doing in the co-requisite and what you're doing in the class. They shouldn't be wondering, why does it feel like these have nothing to do with each other? If they're saying that, that means, we have a disconnect and we need to work on it. Okay, so what should a co-requisite be or have? Okay, number one, it should be extremely easy to sell to students and advisors. And sometimes I'll have schools push back with me and they'll say, and we're not talking about money, I'm talking about persuade them to take it in terms of sell. Sometimes I'll have people, they'll push back and say, well, we just have placement. Like they don't choose whether or not to take it. That may be true, but they choose whether or not to attend. That's what you need to remember. They're going to choose every week whether or not to attend. And we want them to know and feel like that is some of the best time I spend all week. My daughter was, and she's an engineer now, but she was an engineering major in college, and Calculus 2 in the engineering sequence is a core course. It is a make or break course, and they have to get through it, and a lot of students really struggle with it. So at her university, there was no option. Everybody had to take a co-requisite version of the Calculus 2 course. And so she had this extra time during the week. It was specific, how they had it designed and what they did and everything. She's like, best part of my week. So glad I have it. She didn't need it. She would not have qualified if they'd done it through placement, but she's like, she was so glad it was available. And it made such a huge difference in her having success in that course. So this is what it should be. Extra help and extra time, not feel like an extra course with just extra obligations. So it should feel like, hey, it's, sometimes it's hard to get to my instructor's office hours, and I'd love to have a study group, but I've got to work, or I've got kids, or I've got things going on. This is all carved out for them. It should be like, oh, that's so awesome. I'm going to have extra time, not new stuff, just the current stuff in the class, like getting better at it. And I'm going to have my teacher in the room, and I'm going to have my peers in the room, and it's not another lecture. It's going to be time to learn. So that is number 3. If you get nothing out of today, that is the biggest thing I want you to get out of it. Co-requisite time is about learning. That is the number 1 focus. It is not about teaching, although you will do some teaching in it. That's part of it. But you need to be thinking about, am I creating an environment and choosing activities that are leading to learning? That is what it is about. So sometimes I'll have instructors, they'll be like, oh, I had a whole worksheet. I didn't get through all of it. So I just feel like I'm not doing what I'm supposed to do. I'm like, okay, but were students talking? Are they working on things? Are they making sense of content? And they're like, yeah, I just didn't get through all of it. That's still success. It is about them having a chance to make sense of content and learn. It isn't just about doing 10 more problems. Although you might have 10 problems, there's times where you'll have 1 problem and you spend 50 minutes on it. And it's just about making sense of it. Okay, it should absolutely be aligned with the curriculum course. I'm going to show you, so I'm going to give you some very tangible steps how to do that. Because I am curious, let's go into the chat. I'm curious, who can you put your school name if you are a school that has not yet offered a co-requisite and is building one from scratch? So I'm just curious how many schools that is. So if you do not have math co-requisites, you're building them from scratch, please put your school's name in the chat. SATC, previous but not offered in several years. Okay. All right. So it sounds like there's several. I mean, it sounds like a lot of you do have co-requisites and a lot don't yet. So you may really be wondering, like, I don't even know what this is. I don't know what I'm supposed to even create. A lot of you may have something already and it just may not be doing what you want. Some of you may have something that's doing exactly what you want. So I do not want you to think, if I show you something today and you're like, that's not what we're doing, but our students are happy, they're successful. I'm not saying that what I'm sharing with you is the only way. There are other things that can be done. And if you have, I'm curious, if anybody has a super successful co-requisite, the students are happy, you're happy, results are there, it's working. I would love for you to put, because the other people in this chat would benefit from that. Put what your college's name is, and then just give like a brief description of like, how does the class, like what are you doing in that class that's making it work? And it's, it could be, well, we do this every week, or we have, like we have an embedded tutor, and whatever it is, however you've designed it. If anybody's got something that's working really well for them, let's share. Okay. And then the last one is, and this is one I'm very, very insistent on, traditional dev ed is often about breaking complicated things down to simpler pieces. And it's like, and we're, talking about like decoding problems and making things simpler. And that's necessary. We need to do that. But you have to have time spent on putting things back together, because the goal of this is the student can solve a much more complicated problem in a college level class. So we're going to have time where we are intentionally helping them put several things together to get them there. And I'm going to show you a way to do that. Okay, but first, let's talk about STEM versus non-STEM co-requisites. So STEM, I'm talking about, so college algebra, pre-calculus. There are states and schools that use calculus, but probably the most common thing we're talking about is college algebra. Non-STEM is like your liberal arts math, your modern college math, your elementary stats. That's what we're talking about with non-STEM. Okay, so let's talk about what are some lessons from non-STEM implementations. This comes from a lot of the work that we see with colleges and the literature and reports that there's studies, and there's also lots of great like white papers with just awesome takeaways that we can put into place. So here are some of the lessons from non-STEM. 2 hours seems to be a very nice number for the amount of hours. However, that doesn't mean 2 credit hours. It can. It doesn't have to. So one thing I want you to immediately kind of almost divorce in your mind is that time is always credit hours in this situation. It doesn't have to be. Time can be contact hours, lab hours, credit hours. There's all kinds of ways to get more time with students. And that's something that every school has to figure out. It is directly attached to paying for the course and paying for the people who teach the course. So there isn't a one size fits all on how you do that, but it doesn't have to be additional credit hours. But 2 is a really nice number. And so there's some schools that will do 1 credit hour, but it's actually 2 contact hours because it's a lab hour. That's how they'll get the time, and they make it a little bit more affordable for students. But that's one thing to keep in mind. Same instructor is easier, okay? So I have worked with schools that have had different instructors. It's not that it can't be done. I'm just going to tell you it's hard, okay? So if you want to do it, or you have to do it, because I've worked with schools where they don't have a choice. They don't want anybody to not have teaching load. So they're like, okay, we have to have different people teaching it. It doesn't mean it can't be successful. It just means you're going to have to be a lot more intentional. You're going to have to do a lot more planning, and the people teaching it are going to have to talk to each other. And the reality is everybody's department's different. Everybody's culture is different, but a lot of faculty just in general, and I know I can be guilty of this too. We just kind of like our classroom is our classroom, and we're just going to do our thing. If you have someone else that is teaching the co-rec or teaching the college level part and you're teaching one part, you're going to have to talk to them every single week if you want to have a successful co-requisite. Just knowing where you're at with things, what's the goal, what's happening, what's working, what's not, is critical. So it is easier, the same instructor, but it's not always possible at some schools. Now with non-STEM, so this whole, should I offer it be after the support time after the class? Like, we have a Monday, Wednesday, Friday, 10 a.m. college algebra. We're talking non-STEM. Monday, Wednesday, Friday, modern college math. You might want to have, if the class is at 10 a.m., you might want to have the support time at 11 a.m. That's what I mean by after, okay? Not necessarily later in the week, but just later in the day. It could be later in the week though. Sometimes I hear from faculty that with non-STEM, they like having it after. It's basically like, okay, now you saw the class, what do you still need more time with? What didn't make sense and we need to go into? But that isn't magic. You can absolutely have it before and it work well. So I want you to know this. There's been a lot of research, especially has come out in the last couple of years at the state level on Florida and on Texas and different states on what are they seeing that's working. I think Georgia as well. What is working with co-requisites and not? One thing to keep in mind is there are some things that are easier to implement or might work better in certain situations, but there is not a cut and dried only one way, like this is the magic way that everybody has to do it. That does not exist. So I want that to free you up, not to think that, oh, our redesign is inferior because really this is the way we should have been doing it and we can't. That does not have to be the case at all. Okay, commingled or cohorted can work. What does that mean? So, and this comes down to your size. This comes down to the size of your school, the capacity, how many sections of a course you have, how many people are teaching it, whether or not you maybe even have a choice with this. So commingled, meaning you have a class that has people in the class that are getting support. They have to come for the extra support time, and people who are not. So some schools go with that model. Some schools go with cohorted, where everybody in the room also is in the support. And there are arguments to be made for both sides. Again, there isn't one magic way. What I typically find though is math faculty like cohorted and English faculty like commingled. It's not always true, but I see it a lot. So it's kind of interesting. Okay. What are we doing in the the non-STEM co-requisite? It's about just-in-time support and helping students apply certain prerequisite skills, not all of them, certain ones, to the college level content. We're going to see a lot more examples in a second. Okay, let's look at some lessons from STEM implementations, because that is definitely one. I'm always forthright with people, so I'm just going to be very, very honest with you. And there's schools here that I've worked with, so they would tell you, this is what I tell them. It is harder to plan a STEM co-requisite. It is harder to execute on, and but it is absolutely possible. So I don't want to like scare you away from it, but I just want to prepare you. It's not going to come together probably as quickly as when you make one for, say, like statistics. Okay, so the issue with STEM implementations is the algebra. It's that there is so much algebra, and the question is, how much do I do it? When do I do it? Do I front load it? And someone had asked that. Do I front load? Do I just in time? Do I do both? What do I do? How do I make this work? So the suggestions I'm giving you are based from faculty, things I hear that faculty like, that they are seeing the most success with. Again, this isn't the only way. All right, so first thing, you have to get the right students in the room. This is not trivial, and we already had some people asking about this. So one of the things is, when you are figuring out your co-requisites, this is not a math department initiative. I cannot stress that enough. So if you're checking email, come back to me. This is not a math department initiative. This is an institutional initiative. So when you go to actually build your co-requisites, you have to have a cross-campus team. You've got to have administrators on it. You've got to have people from student affairs, particularly registration and advising, and you have to have faculty. You cannot only have faculty. I've had situations where there was no faculty in the room, and I'm like, okay, well, we can't do this. We can't start fiddling with math classes, and we don't have anybody who's going to be teaching them in the room. Likewise, we can't start fiddling with how many credit hours or something, or getting students registered for it, without the people who do the advising and registration. If you do, you will end up making decisions that you are very well meaning about and not even realize it's not actually going to work for students. So save yourself time, get all the voices that you need in the room. Then you've got to have a conversation about what is our actual intake process? How do students get from when they decide to I'm going to, Neosho County Community College. Once I decide that I'm going there, what are the steps? What is the process that happens before I ever step foot in the classroom that I'm going to take? And you have to find out, you have to look through that process, that whole journey, and see, is it working or not? And probably there's something that isn't working. I haven't seen a college yet that it's perfect and working, but you have to really analyze, how is the student getting the decision made for them, or are they making the decision that will get them into a college algebra or pre-calculus class? The problem is that students assume wrong. They're a lot of them, especially if they come straight out of high school, they're going to be like, well, I took math in high school, I got to take math in college, and math equals algebra in their mind. So they're going to be like, I'm in college now, so I guess I take college algebra. And there's a bunch of them that do not need to be sitting in that room. Okay, so you're going to have very overt conversations about how are students getting into the college algebra class. And actually, one of the most fun things you can do, anybody who's teaching college algebra right now on Monday, is do a quick survey with your students. You can do it on a piece of paper. You can do something fancy, and make a survey electronically. But you could just ask students, if you don't have too huge of a class, why did you take this class? Like, how did you actually get into this room? Did someone tell you? Did you pick it? Did you make an assumption? Did you know your program required it? Like, why are you in this class? And listen to what they say. It will tell you so much about what is working with advising and placement and what isn't, because you only want students in that room that know that their program or transfer institution or current institution requires college algebra. If in doubt, that's not where they should be. And don't do the just in case. That is not a good idea, because this is a very hard course that a lot of students are not going to pass. So we do not want to put them in there and be like, just in case you change your mind or you go into STEM. That whole theory only works if they are successful in college algebra. And nationwide, half of them aren't. Okay, so, and I can give you the citation for that if you would like it. You have to be really thoughtful and intentional about where you're going to put in prerequisite review. Okay, so when you're going to do it, how often, how you're going to do it. I want to give you some ideas. So, I'm sure I have it somewhere. I will make sure I hit that. I thought that was going to be the next bullet point, but that's fine. It is much easier to have the same instructor in here. Again, not impossible, but I will say, boy, if you could only have one course where you can have the same instructor, and you had to choose between the non-STEM and the STEM, choose the STEM to have the same instructor. You need that continuity of understanding what we're doing and how much algebra do we need to cover and when, and what do we need to review. Okay. You want the goal of this is that we have this seamlessly integrated co-requisite support, that we are just like, and we have the same instructor. It just makes it so much easier to actually accomplish that. It doesn't feel separate. I do hear faculty like a lot of times having the support time before the college level class. So they might say, if you have a 10 a.m. class, maybe you have a 9 a.m. support, because that allows them to do a preview. Now, if you're like, we can't make that work with our schedule. Most colleges can't. Most colleges can't schedule just things like that. Like, our schedules are so complicated and there's so many factors you have to think about when making a schedule. I do not want you to get tripped up and think that has to happen. It does not have to happen. But if you can get it, there are some perks to it. Having the support before the class, and you can preview some things that you're going to do that day. Okay, cohorted is easier. Okay, meaning everybody in the course is getting the extra support. Now, you don't have to. You could have people that aren't, but again, it just makes it easier, and especially with a harder co-requisite, it makes it easier when everybody has the same issue. Everybody needs more support. Let's focus on that. You should absolutely consider some kind of courseware, and there's all kinds of stuff out there, and not all of them have a cost. You could do My Open Math, that's free. My Math Lab, Alex, whatever, WebAssign, or Hawks, pick a platform. But the idea is, all of these students that are sitting in a STEM co-requisite have a need for better understanding of their algebra. However, it's not the same algebra. It is different algebra for each student and different levels of need. That is where software is better to actually customize the experience. So you are not trying to customize it for everybody. And also, you're not just giving everybody the same amount of practice on every skill, because that's going to be too little for some and too much for others. Okay, boot camps. All right, so if you're wondering, how in the world do we make a STEM co-requisite work? I would say building a boot camp is one of the best things that you can do. You can call it a bridge program, call it whatever you want. But it is a short-term, very intentionally designed experience where, this is the way I think of it. If you have a student that's coming in, so here's two things. One is, if we only have students taking college algebra that need it, you're very unlikely to have your highest need learners. You're not going to have people that go into STEM fields that cannot basically do third grade math. Okay, I'm not talking fractions. None of them can do fractions. Okay, I'm talking 2 times 4. All right, so typically, if you've got the right people in the room, you're not starting with your highest need students. What you're starting with is, because students that have the highest need in math are typically not going into any field that's going to require much math. Okay, not always. There's exceptions. Okay, so what you're going to be dealing with, your lowest needs are probably students that are at the beginning algebra level. Okay, if you have a really well-designed boot camp or bridge program, you can overcome the gaps that they have at the beginning algebra level, and then the co-requisite with the college algebra only has to do the intermediate level. It doesn't have to do everything. So you're not requiring that co-requisite to do so much in such a short period of time. Okay, now we could have a whole conversation on boot camps. The main thing I want to say is, these are not mini courses, meaning they're not 7 weeks or 8 weeks or anything like that. You can literally do a boot camp in a week. It is a short experience. It has a very intentional outcome that we are trying to determine what are their algebra gaps, and we are going to try to address them. Okay, I do not work for the company, but I will say a lot of my schools love using Alex PPL for this, because Alex has data on the validity of their scores. And we know that, like, if a student comes in and they take the initial ALEKS assessment and they will work at least 5 hours. They almost always place up a level, and a level is a course. So if they come in and they're at the beginning algebra level, if they will go through 5 hours in it, we can probably get them to place into intermediate, and then the co-rec doesn't have to do so much work. Okay, so that's when, if you're like, how am I going to make college algebra work? A boot camp could be the key to it. Okay, but keep them short. And this is another thing. Do not just sit students in front of computers for a week and expect the magic to happen. There will be no magic happening. Okay, the best thing that you can do is have varied activities throughout the time, where you're doing, like, okay, we're going to maybe say you are using ALEKS or My Math Lab, whatever you're using. Maybe you have 20 minutes where they're going to work on their individual plan, because all these programs have where they can form an individual plan, or most of them do, for what are the things that the student needs to work on. Then after 20 minutes, because that's about all they can sustain before they're going to be on their phones anyway, not to say that they won't be on their phones in those 20 minutes, because let's be real, they will. Then bring them together and actually do something active. Actually do some kind of like activity, something real, something kind of group, or you can, I'm curious, you can do thumbs up or you can do it in the chat. Yes. Is anybody using or familiar with building thinking classrooms? Those techniques. Has anyone ever heard of building thinking classrooms? Okay. Because there are amazing techniques with, it's a great book. Again, I don't work for the company, but I do contract people that work for the company, because the content is really good. And the concepts and the way to get a classroom, getting students up, getting them talking, getting them working on math, getting them thinking, not just writing and watching. So there's, that would be another day, but I just want to provide that. Okay, so I did leave this off. Okay, so let's go back to the second bullet point. Thoughtful and intentional on prerequisite review. So this is what several teachers that have been testing out college algebra co-recs really like. They do some front loading and the rest just in time. Okay, so what do they front load? They front load, meaning they take like the first week to week and a half and review the beginning algebra concepts that they know they're going to be doing every single week for the rest of the semester. So things like factoring. Okay, let's be real. They never remember factoring, even if they learned it yesterday. So factoring, slope-intercept form, order of operations, solving linear equations, exponent rules. Okay. Notice I'm not saying rational expressions. I'm not saying radicals. I'm not saying quadratics. You don't have to do everything. Pick the things from beginning algebra that you know that you are going to be doing with them every single week of the course, okay? And front load it. Now, how do you do that? You can basically do what I just explained with almost like a boot camp, but do that during the first week. You're not going to teach a lesson on every single one of those. There's not enough time for that. What's great is to use some kind of courseware, figure out where to do, or make a quiz, however you want to do it, but get a diagnostic so you can figure out where are they at with these skills so that you know and the student knows, and then do some intentional review so that they can improve their skills. I've used it many times over the years. I'll use the, in my math lab, the personalized homework with a quiz. I'll make a quiz in my math lab that has like all these skills in it that I'm talking about from beginning algebra that we care about. And I have the students take the quiz and I tell them, if you like your score, you're done. If you don't like your score, it's going to generate a homework to work on only the things that you missed. So it's not going to have all the things in it. It's just going to have the things in it that you need more help with. You can work on that. And then you can take the quiz again if you like. Best score counts. That works in so many classes. I cannot tell you how effective that works in especially if it's a class that has a lot of algebra base in it. So like if you're talking calculus, it's just a great technique. And if you're like, I've never heard of personalized homework, if you will literally Google, not now, because you will miss the fun, but when all this fun is over today, but you can go Google My Math Lab personalized homework. There are explicit instructions, a video, everything. It's very, very easy to do, and it will rock your world. Once I learned it, I tell anybody I can, because it is just a very nice feature. Okay. Now, I've already talked about front loading. So you do that at the beginning of the semester. Then you're going to do just in time the rest of the semester. Now, here's the key to this. So I want you to think about, let's take radicals as a perfect example. Okay. So let's say you're in the lesson and you're in college algebra and you're teaching a lesson and it's on radical functions. Okay. What you're going to do is you're going to have some just-in-time support on radicals. However, you are not going to do everything that was in chapter 8 of your old book, okay, of your old intermediate algebra book or whatever book you were using. You don't need to. Some of that is overkill. Some of it they will never see again. And some of it we don't do enough of, okay? So what you're going to do is have an intentional use of the parts of the radicals that students need to know based on the different things that you are doing when you do them. So if you're wondering, how in the world can you get through everything in intermediate and college algebra? Because you're not going to do everything that we used to do in intermediate. There were things there that I just don't think intermediate. I've never thought it was a great course. It's too abstract. It's really difficult and students do not see the point of it and they don't remember the skills. Even if they do well in it, they typically don't remember them well enough to apply it to the next course. It doesn't do what we want it to do, even when students pass it. Not to say the content is bad. It's the way we lay it out and put it and we package it is part of the problem. So being really thoughtful about when you're going to do radicals, when you're going to do rationals, and how much of them you're going to do. And always in service of the college level content. We're not just doing it to do it. We're not just going to be like, oh, let's make the ugliest radical problem we can ever make and simplify it. Or even better, let's solve a radical equation that has 2 radicals in it where we have to square both sides twice and we get extraneous solutions. The fun never ends, okay? We don't have to do that just because we always did that, okay? Although, I mean, there's times where that does happen in calculus. But let's be real, is it going to happen immediately in what we're dealing with in college algebra? It may or may not. All right, let's talk about co-requisite course content. Okay, so what, when, and how much, how to approach this. Okay, so here's the first thing. We are not, I know I've said it multiple times, but it's, trying to be repetitive on the things that really, really matter. Don't just start with everything you ever did and try to smush it together. Okay, start with completely differently. You start with the college level course. You start with it and you work your way back. Okay, I want students to be able to pass this course. What are the things I'm going to need them to be able to do and know? And then I'm going to work backwards and include those things. Okay, not just everything we ever did in Dev Ed before. That means that there will be things that you drop. You will also add things that you weren't doing. That will happen, and that is okay. All right, non-STEM, you're going to be focusing on just-in-time support and helping students apply prereq skills to content. We've talked about that. This typically happens. So in non-STEM, by the time you get to about the halfway point of the semester, you've run out of prerequisite skills to go over. So like if you're saying you're teaching like modern college math, the prerequisite skill list is pretty short. It's going to be like order of operations, linear equations, solving them, graphing them, maybe exponent rules, maybe not. It's, fractions to decimals per 2%, rounding, some things like that. By the time you hit week 8, you've probably hit everything that you need, not necessarily, but often. So the question I'll get from faculty is, so what do I do the rest of the semester? You're not going to just add in more prerequisite skills because we need to do more of them. What you will shift to is you will have more developmental content earlier on, and you will have more college content focus later. And that's okay. You'll still be reviewing fractions to decimals percents. Let's be real. You will forever. We'll always be reviewing that. But it's not going to be teaching a bunch of new skills just to fill out the 8 weeks. Okay. Whereas with STEM, you're going to have new stuff the whole time. Okay. Let the college level content dictate the amount of algebra to include. I am giving you freedom to not feel like you have to do everything you ever did before. So everybody teaching stats, you do not have to include factoring. I said the F word. Okay. You really do not have to do it. All right. You don't have to do radicals or rationals either. So we're just hitting all the big ones. Okay. STEM, we already talked about this. You have to be really intentional about the prerequisite review. That's where I finally put the front load and intersperse. I will be providing these slides. Actually, I think I've already provided them to Whitney. I just need to make sure I check the permissions to them, but you will have all of these. So don't worry about trying to remember all this or write all of it down. And I probably should have told you that an hour ago. So I apologize for that. But again, yes, you're going to do some intermediate. Yes, you're going to do some beginning algebra, but it's not going to be exactly as much or in the way that we did it before. Now, if you're wondering, okay, so we just don't care about standards anymore. Rigor is just off the table. This is not true, okay? I do not want you to think that we are reducing the expectation of the course. We are not, okay? We are addressing the needs that they have to be successful in that course differently. We are not reducing the rigor. Okay. So here's something I want you, now this is for anybody, and it doesn't matter if you're building a co-requisite course or maybe say you're working on another class. Maybe you're in a place where it's just like, our finite math isn't working that great right now, or our calculus is still really not what we want it to be. I want to give you kind of like a framework of what you can do to make any course work better for you and your students. Okay. So first thing is, and I'm talking college level course. I'm not talking co-requisite here. I'm just talking a college level course. First thing is start with what do you have to do by either transfer or the outcome program or the degree, or maybe if it's like sometimes for like a technical program, maybe they have an external test that they have to take. And so there's certain things. What are the must hit objectives, okay? And really understand what do you have to do so that you maintain all of your agreements and you're satisfying your obligations so students are going to be ready for wherever they need to go afterwards, okay? Then we start cutting. We start cleaning the closet, because the reality is, and if you're thinking, I can't, there's nothing I can cut. You absolutely can reduce emphasis some places. There are places where we treat every skill like it has equal importance, and they just don't all have equal importance. So the reality is there are places where you can get more time and have the time on the things that really matter if we de-emphasize some of the things that you might be wondering, like, why did we ever do this? Before you delete anything, make sure it's not going to cause problems and make sure we know if it's really needed or not. And before you reduce emphasis, make sure that you've thought through the implications of that. But there are usually places where you can clean the closet a little bit. And because what happens is our courses get bloated over time. We just keep adding and adding and adding. We don't remove enough, because if you get a bunch of math people in a room and ask them to agree on what to remove, you're going to be there a long time because we don't agree on those things. So that's why things don't usually go away. Okay. Then one next thing is determining what are the most important objectives and level of assessment. And if you're sitting here going, why are we talking about this in the land of co-requisites? Because this is what you have to do before you build a co-requisite. You can't build a course to support something that itself doesn't work. So you need to look at the college level course first and make sure it is doing what it's supposed to do and clean it up, instead of trying to build some support for something that is just really flawed in its current form. Okay. So it's really funny. My roommate and one of my closest friends, Dr. Maria Anderson, she was a math faculty member for a very long time. And she also ran an ed tech company that built course software related to curriculum design and instructional design. And she sold that company a couple of years ago, and now she's teaching math again. But she coined this, and I love it. And it basically kind of just blew my mind when I learned it. It's called the ESOL lens. And the idea is thinking about every objective in terms of how important is it? Who is my audience? What do they need to know? Because that is going to directly impact how am I going to assess it. So do they just need to know this concept exists? And that's good enough. I just need to expose them to it. If that's the case, it's probably not going to land on a test because it doesn't need to. Okay. Is this something that the student needs to be able to do supported with? Maybe they're looking up notes or they're working with someone, which, for the record, I've been married to an engineer, my husband, for 27 years. Okay. They look all kinds of stuff up. They do it all the time. All right. And they talk to their peers. There's all kinds of things in the real world that happens. So it's not like, well, we can't put a bunch of things on that list. They're not always going to be able to look it up. In the day and age we live in, the answer is yes, they probably will. Now, I guess there are cases where that's not true. If someone is trying to like perform CPR and they're dealing with a life or death situation, there are times when you're just going to have to know how to do something independently and know how to do it well. That's different. Okay. But those situations don't always occur as often as we think. Okay. So we have to be a little bit more discerning about when they do. Okay. Independent is you have to be able to do it independently. We treat a lot of things in math like everything has to be learned. You've got to be able to do it independently, meaning on your own, no notes, no support, time test. That's the way it has to be done. And the reality is that just isn't true for a lot of concepts. There's a lot of things where if they could do it, looking something up and do this in a supported, way, that would suffice. That will suffice for everything that they need in the future. Okay. Some cases, I'm not saying that's with everything. And then lifetime. What are the things that they have to know and they've got to be able to do it for, basically the rest of their life? That's not going to be a super long list, but usually it exists. There are things that just they have to know and be able to use for a very long time. That mainly the reason I'm showing you this is because I want you to start trying to think of your course differently. I want you to start thinking about what are the things that really they've got to get. What are the things that if they get with support, that's okay. And what are the things that I just really need to expose them to? It will really help you be able to teach and assess in a different way and hit more needs that the students have now and in the future. Okay, which sounds very Pollyanna-ish, which if some of you may be young and not know what Pollyanna is, but I'm old, so I do know what that is. But it was a wonderful movie, and the girl was perpetually happy and optimistic about everything. Okay, then once you get this figured out, then you're actually going to choose those assessments. How are we going to assess these different objectives? How often? In what way? And then you figure out your support content. Okay, how am I going to help the students who need more support, which for the record is all of them. Okay, all students can benefit from co-requisites, and you will have students that will ask, can I take the co-requisite even if I'm not required? Because it is beneficial. But this is when you determine both the math content and the student success content. More on that in just a second. All right. So this is something, and again, we're not going to do, I want to respect your time. I want to be able to hit all the things that I know you have questions on. So I'm just like, I'm trying to, and of course I talk fast. I apologize. I've been told that my whole life. But this is something, I'm putting this in here that I want you to, and not every college needs to do this probably, but some of the colleges this would apply. I want to show you kind of basically a basic backwards design activity. And again, you're going to get this slide back. Okay. So what you would do is you're going to start with, pick a math course that you're working on. So say it's modern college math, okay? Liberal arts math, QR, whatever you want to call it, okay? And we're thinking, okay, I'm going to build a co-requisite for it. So before I do that, first thing I'm going to do is determine what course am I working on. Second is, where do I want to get to? Like big picture, what's the goal of the course, okay? What is your true goal of the course? And think about, what does that actually look like? So when I'm teaching stats, my goal is that they don't get hoodwinked by how stats are used in the media, that they are discerning when they see statistics and when they see things about polls and margin of error. Let's go to the election. That's a non-controversial topic. But whatever, that they're looking at, I want them, when they see statistics in real life, to have a sense of what they are and not be terrified of them, and also be able to understand that statistics can be used to manipulate, conclusions. And I want them to be aware of that and have their, just their awareness on. Okay. For college algebra, it could be, I really want them to be able to know the algebra well enough to be able to use it in calculus. It could be, I really want them to understand the different kinds of models, that they understand linear versus exponential versus logarithmic versus polynomial. Like, I want them to really understand that. Whatever it is, figure out what is the point of the course, okay? Then, what are the current problems with the course? This is fun, okay? You just start listing. What are all the things that are not working with the course? And list all the things that are. So, because we don't want to just, get ourselves down, because there's no way that all of you have a bunch of courses where there's nothing working. That just isn't true. There are probably some things that could be tweaked in probably every course we teach, but there's probably some things that are working quite well. Okay, make note of them so that you can know, okay, we like that. We want to keep that aspect, but this isn't quite doing what we want. So my classic is always, I never have enough time. There's too much content and I never feel like I have enough time to get through all the stuff that I need to do. Okay. So my issue is always the pace and the amount of content. And then sometimes it might be, I feel like this course is really irrelevant and not connected with what they're going to do in the future. I feel like we have things in there that don't make sense. It could be a whole variety of things. What's working, what's not. Okay. Next thing is you're going to make a table. You can just pull up a Google Doc or a Word document and have 2 columns. And what you're going to do is on one side, list all the college level content that you have to have for that the student has to learn in that class, and then list the prerequisite skills that go with it. Now, here's what's really cool. We are not in the first year of co-requisite implementations. A lot of people have been working on co-recs for a long time, some over 10 years. There are documents like this that exist, okay? I remember working with Dodge City. One of the books that they used, the author had in my math lab, they had a whole table and a guide. Like, here's all the concepts, here's all the prerequisite skills that go with those to be able to do those concepts. So we did not have to invent the wheel. We had went and looked at it and like, do we agree with it? And does it say what does it match the course that they were teaching? And was there anything that we needed to adjust? Okay. So first column, what is required, or I don't care what order you pick. One of the columns, what is required. And again, remove or de-emphasize things that aren't as important as we may have once believed they were. And then determine what are the prerequisite skills needed for each topic. And when you do this for a non-STEM course, you will see the list is really short for the prerequisite skills. I gave you the list earlier, but it's not that much. It's a little bit of pre-algebra, a little bit of beginning algebra. There's usually nothing from intermediate algebra in it. Okay. Now let's go more into the classroom level. Okay. This was the course level. We were talking about all these different things with building the course and what you're going to have content in it. And when are you going to do that content and everything. All right. Now let's talk about classroom. Okay, what am I actually going to teach? How am I actually going to do this in a day in and day out? So this is my 3 pillars of the pieces of co-requisite content that you really need to include. Okay, and here's what is so cool. I have the best news for you in the world. You don't have to create any of this. Okay, I'm going to show you all kinds of stuff that already exists. You have to choose things, but you do not have to write anything unless you want to, okay? And some people are super creative and they love creating activities, but don't feel like that's gonna be a requirement. Okay, so the first part is the part that most of us think of. Co-requisite content, I'm probably gonna be doing some of the prerequisite stuff. I'm gonna be doing some things that we used to do in beginning algebra or intermediate algebra or pre-algebra, okay? Yes, you will have that because the goal is we're going to try to address the skill gaps that exist, knowing that they're not the same skill gaps for every student. Okay. This is an outstanding place, as I mentioned earlier. Use technology, allow it to help you differentiate the experience for students in a more doable way for you and them. Okay. Super important. Not enough on its own though. Second piece is student success. And I've really evolved on this. I used to think we need to scatter student success concepts throughout the class or throughout the semester. Basically, we need to be incorporating this every time we see them. You really cannot do too much of this. And if you're like, well, what do you mean by student success? It can vary, okay? And I'm going to give you a resource that you can use that has, again, so much stuff. You don't have to create anything. But if you want to see some really awesome student success content that exists and is free, okay, you can just have it. And I know you can have it because I was at a session yesterday where the speaker said anybody that wants this can have it, and I've seen some of it before. And it's quite good. The idea is it could be an activity, it could be a note on something, a tip, something to keep in mind. But it's that college knowledge, it's that information that we often assume they know or they already got someplace else in the college, like they took in a freshman 101 class. And I'm sure they learned all of it there. Even if they did, that doesn't mean they can apply it to math. So don't assume, and don't be worried about saying, well, they probably all know that. There's someone who doesn't. So it's always worth saying those things out loud. So perfect example, if I was teaching a co-requisite class on Monday, one of the things I would be asking my students is, hey, it's really late in the semester. It's November. Do you have your spring schedule yet? And some of them are going to be like, didn't know how to do that now. I thought you did that in January. No, I probably want to figure that out pretty soon. And maybe like go sign up for those classes so that we actually have them and we take them. And they may not even realize they may have another math class they're supposed to take and be like, do I really need to take it next semester? Does it even make a difference? It does. You probably should take that right away, especially if they have like a sequence of courses. Let's not put that off. So that's a conversation. That's student success. You might have a 10-minute activity some days. You might have a 5-minute discussion with them. It doesn't always have to be big and elaborate, but it needs to be there. Okay. So here is, okay. So I've got some really good questions and comments in the chat. I will get to those in just a second. I'm pretty sure this is the site. Okay. I believe it is anyonecanbeamathperson.com. Jessica Bernards is the professor. She's out at Portland Community College in Portland, Oregon. And she has put together a whole set. They're super cute, which I know everybody was like, well, that's how I pick my videos. They've got to be very, very cute, but they are. She uses this software that it's very pleasing to the eye. They're short and they're good. They're really strong videos. So she has a whole bunch of videos that are on YouTube that are free that you can use. And she also has activities that go with all of them and how to use them. Now, she may or may not have a link on this website right now. She said yesterday, she's like, I may not have the link to the drive where all of these things are on it. I'm making a note right now. I will put the link in my slide deck so that you have it either way. But okay, so link to Jess's content. Okay. All right. Student success, we got to hit that. Third piece is something I coin. This is what I call bridge content. I'm a really big believer in this. Call it whatever you want. You don't have to have a fancy name for it, but it's the idea of specifically addressing the gap between developmental and college level. How do we bridge that gap? Now, the fancy educational way of saying we're going to scaffold learning. Great. And a lot of you already do this and don't even realize you're doing it. But what I want you to know is that it matters and why it matters. Okay. So the reality is, and I'm going to give you examples of this. Do not worry. You're going to see what this looks like. The reality is that, let's say we're talking about, let's say it's a statistics class and they're doing correlation and regression, and we're dealing with the regression line equation. Okay. So y equals mx plus b. It is not enough just to do the prerequisite skill and say y equals 6x minus 7. What's the slope? What's the y-intercept? Because that's not at all what it looks like in a stats book at all. That's not what it looks like on their calculator or necessarily on a computer, depending on what software they're using. Okay. Different symbols. Sometimes the X term comes at the end. And then the numbers are all ugly. They usually have decimals in them. They're quite long. And then the whole point is not just, can you identify the slope? It's what does the slope mean? What is the rate of change that we're actually talking about in this contextualized situation when we're dealing with correlation and regression? Okay. So if you want to get to the student to the point that they can do problems like that, we need to bridge the gap. You can start with that prerequisite skill, y equals 6x minus 7. What is the slope? What is the y-intercept? Can you graph this? Can you locate the y-intercept? Can you use the slope to move up and over and get to another point on the line? Great, but that's not enough. The other piece you need is you need to bridge that gap up to the kinds of problems that they're actually going to have in a stats class. And I'm going to show you what that looks like in just a minute. Okay, and what's cool is there's lots of ways to do this. There's not one right way. I just want to give you some examples and show you where you can get tons of cool stuff, again, that's free and that you can use to help you bridge that gap. And if you love to write stuff, you can do that too. Okay, so I want to briefly mention something. So I'm curious, by a raise of hands or just in the chat, has anybody ever heard of QuantWay, StatWay, Dana Center's Math Pathways project and New Mathways, math literacy? If anybody's, this is a like, yay, I love when I hear people say yes. So this was a project that I joined, the developmental math pathways started in 2009. And I worked on this at the national level with a MATIC and also with Dana Center and Carnegie when it first started. And I was part of the initial discussions with a group of faculty. And we were told, I remember sitting in a room, we were at the Gates Foundation in Seattle, and we were told to put our hats on, imagine that we were kings and queens. If we could make developmental anything that we wanted, what would it be? Okay. And to think outside the box and think big and dream big. Okay. And all kinds of things came out of it. So I will tell you, I wrote a math literacy textbook. Again, I'm not selling you a textbook, but I am like, particularly, this matters to me in so many ways, because it was like, wow, we can do math at the developmental level that is really aligned to the college level course and is relevant and interesting. And it was so exciting. Okay. You might be saying, Kathy, I can't teach that class. Why are you even telling us about that? Doesn't matter, because there's so many good things that we did in those courses that you can use to make your co-requisite work. Okay, so let's look at it. Number one, that all those courses, those pathways courses, were designed intentionally by faculty, and they were iterated and tested over time. So that is one of the things that I want you to do. I want you to talk to faculty in your department, or if you are the math department, and some of you might be at a college where you are the math department, talk to other people in your state about, I'm trying this worked, this didn't work. But you have to refine and have conversations about your co-requisite. You're not going to get it perfect straight out of the gate. It is going to evolve over time. That's good. Those conversations are where some of the best changes will come. Okay. Secondly, we did not do everything that we had ever done before in those courses. We culled the content, we cleaned the closet. Okay. And we looked at every single objective with a very discerning eye. Does this have to be covered? Is this essential? And if it isn't, it went. And if we were missing things, we added them. Okay. We spiraled. Okay. Huge tip to anybody teaching co-requisites. The spiral approach, where we come back to things over and over and over again, not like, let's just hit a topic to, like, let's beat it to death and then move on to the next thing. The idea of spiraling is seeing something over and over and over again and progressing over time. It works. It's how our brains work. That's how we learn. So if I was teaching stats co-requisite on, throughout the semester, or if I was doing liberal arts math, modern college math, I would be reviewing decimals and fractions with them the entire semester. Every time I got a chance, I'd be like, hey, let's do a couple quick questions. I want you to, change this, decimal to a fraction or vice versa. Or here's always a really fun one. You're going to get a p-value and the calculator is going to say 4e - 5. Can you write that out as a decimal point? Things like that. I'd be doing that all the time because they can't see it enough. Anything that we can do in terms of bringing it back, doing it again in a different way helps them learn and retain. We embedded student success content. We didn't just say, yes, let's do that the first week, or let's do that in a separate course. It was throughout the entire course, and it was very intentionally used. All these developmental pathways courses, didn't matter who made them, because all different kinds of groups and publishers made them, but those things were included. We really emphasize relevance and problem solving. That is excellent. That's what you want in your co-rec, as a lot of anything we can do that's relevant and problem solving, not just watching you do problems and them taking notes, but actually them solving problems together and talking about them. Lots of active learning, way less lecture. Okay. That is very useful. It's hard. I will be the first person to admit it's hard. It is, but that is something that makes the experience better for students, and it makes learning happen. Okay. I'm not saying you can't ever teach directly, but we need to have more time where students are talking and doing math than just us talking and doing math and then watching it. We incorporated technology intentionally, often, and taught them how to use it and why we cared. We did lots of different kind of practice. So this is one of the things that I think kind of gets overlooked is, I think anybody here that's a math teacher has heard this in their life. Like if a student does a problem on the computer, you could put that same problem on a piece of paper on a test and they'd be like, we never did that. Because it looks different when it's on a screen compared to how it is on paper or in a book. Okay. And a lot of times their thinking is very inflexible. We need them to get used to doing things in lots of different ways and seeing lots of different formats and being a flexible thinker and learner. So one of the things that we did in this course was we'd have online homework, we'd have paper homework, we had all different kinds of things so that we could have students growing varieties of skill sets. Okay. And we applied things to college level content. We did not just stop with the developmental, we applied it to college level content. All right. So what I want to do is give you, this doesn't have a cute acronym. If someone comes up with one, please let me know, because that would be awesome. But this is a framework. It's funny, I'm actually using it right now. I use it with every talk I do, every workshop I do, and most of the classes that I teach when I'm planning appropriately in my world. I'm not saying this is the only way to do things, but for me, and I'm not just like winging it, this is the approach I use when I'm planning my classes as well. So the idea is, instead of walking into co-requisite time and saying, today, this is what we're doing, just stop and start with, what do they need? Assess them. And I don't mean it has to be a quiz. You could do a quiz, but you don't have to. It could be literally, okay, what was hard about the homework last night? But you can be way more creative than that. There's all kinds of really interesting ways to get information from them on what do they need more or less on, and then use that to determine what you're actually going to teach them. Okay. So this is the part that makes some people uncomfortable, because they're like, but that may not be what I thought it was going to be. That's okay. This is the part of like where I said earlier, we want co-requisite instruction to be flexible yet intentional. This is what we're talking about. You're going to have to flex a little bit. Even though we plan, we're going to have to adjust how much and what we do based on what they need. Okay. And again, I'm going to give you a very concrete example of this in just a second. Okay. Second thing, we're going to be either teaching or reteaching probably some kind of prerequisite skill, or it could be a college level concept. It could be either one. Okay. That does not mean you have to get up and do a mini lecture. I mean, you can, but it could be, okay, let's quickly review how to change a number in scientific notation to standard notation. How do we actually do that? We could do a quick review of it and then give them some problems and let them work on a group, or put them up at the boards. You can put them up at the boards in groups. That's really nice. Then they're not so intimidated. They can work on problems together. But get some skills in there and reteach if there's anything that they need. Okay. They may need a lot, they may need a little. Equip is my fancy way of saying, give them those student success concepts that make a difference in being successful or not. Give them some tools or an activity or a tip that we were talking about earlier. Get that student success idea in there every time you see them in some way. Okay. Fourth thing, scaffold. So this is, again, the very fancy way of saying we're trying to bridge the gap and build the bridge from the developmental content to the college level content. That's those bridge problems that I mentioned, and I'm going to show you examples of in a second. And then the last part is apply. Actually use all of this in a college level problem. Okay, so I've taught math for a long time and I know a lot of math faculty. Okay. It's almost too tempting if I told you that your co-requisite class was 50 minutes long for you not to look at this and go, oh, so I do 10 minutes on each of those. You do not have to do that. Okay. It might be 2 minutes on assessment and 20 minutes on apply. It varies. This is the part where you have to be a little willing to bend and flex. Okay. And the more you do it, the more comfortable you'll get with it. Any of you that have had background in teaching K-12, this is going to come more naturally because you had to do this in K-12. Okay, so I will say that you have a leg up. Anybody that was primarily a developmental instructor is going to have a huge leg up because you are probably more used to doing this. Okay, so, and I'm not saying that primarily college level faculty don't know how to do this. A lot of them do, but some people, and because they'll tell me, they're like, I'm used to doing the problems that are in the book, and that's what I do. And so I don't really know what else I'm supposed to do other than that if they need help. I just thought we'd do more examples. And it's like, you can do some examples, but we need to do some other things too. So this gives you a structure of how to do it. Okay, so yes, please try to get creative with your assessment. Do not feel like it has to be a quiz. I mean, you can do one that I've done is I literally stand at the door with a set of Post-its and give everybody a Post-it and say, write something on it that you have been struggling with in this class, like in the last week, and go just attach it to the board. And then I can scan through and see, oh, okay, so they're, clearly this, this idea is not hitting yet. But there's so many ways. And again, I'll give you more examples in a second. I'm actually doing this right now. Like one of the first things I did was I was trying to ask you more about yourselves. And then I've been teaching, but I've also been giving you tips on how to use this when you teach. And I've also been trying to bridge you up to the point of where I'm trying to get you to do is be able to apply all these concepts and teach your co-requisite in a way that works for you and your students. So I'm trying to slowly get you there very intentionally by the types of things I'm teaching you and having you do and think about. Okay. Yes, we are teaching, that is part of it, but that's not the only thing we do. And it's very tempting to think that, like in a co-requisite, you're going to be at the board the whole time. Not necessarily. And I would not suggest actually being there the whole time. It'd be great to have students there a lot of the time. Okay, this is what you need to remember. Students are thinking every single day before they come to a class, they are thinking, is there a point of me going? Like, is it going to matter? They are debating, just like you probably debated. Do I have to go to this? I know they told me I have to go. Do I have to go? It's 2 hours. It's a lot. She's probably going to be boring. It's like, do I have to do this? Let's be real. That's what we all do. What is in it for me? You've got to make sure that you're thinking about your co-requisite classroom that a student would be like, this is going to help me. I'm going to get to talk to my peers. I'm going to get to talk to my teacher. I'm going to get to work on stuff. It's not just going to be more assignments, and I'm going to get time to actually make sense of this stuff. That is not how they would say it. Okay, I get that. I have children, like my son is 20 and my daughter's 24. That is not how they would say it. But the point is, they are thinking like, I want this, I want to go to something that's worth my time. And so we want to build an experience that is effective, but also worth their time. Okay. And if you do that, you will fight less with trying to get them to come to class. All right. So here's a more specific example. And by the way, you could use this with non-co-requisite classes. You could use this with any class. Okay. But here's what this could look like. Okay. So starting with assess. If you're the only teacher that is doing the college level and the developmental, you might have had where, let's say you're doing that Monday, Wednesday, Friday at 10 a.m. you're teaching the class, 11 a.m. is the co-requisite. Okay. So you could say on the 10 a.m. class, before you leave, I want you to fill out a quick piece of paper and leave it on my desk or a note card or something. It's an exit slip. You need to give me this to get your points for the day or whatever before you leave. And it could be, what's the thing you're struggling with the most? What do you need more help with? What was the hardest thing that we talked about today that is not quite working for you? Sometimes people call this, what's the muddiest point? Whatever, but you just ask them directly. Or you can do things that are a little bit more interesting. So one faculty member, she told me that she did this. And I was like, God, that's clever and smart. She will have students, she'll assign a really short Desmos activity that's on some particular concept. It already exists. She didn't make it. She found it. She assigned it to students. And all she does is she goes in and looks at what are the results before she starts her co-rec class to see, okay, I wanted them to work on this concept. How did they do with it? Some people just go in and then they look at their online homework system. If you had an assignment or something, what was the problem that was most missed? What were the things that they spent the longest amount of time on? Assuming they just didn't leave their computer on and go make a sandwich, but like trying to look at like, what do they need more help with? But there's no limit to the different ways you can find out what do they need more help with. And it's not just always help with in terms of math. This is also the time to get a feel if there's anything else going on. Because, I mean, let's be real. Last week, we had a very big election. It's entirely possible that you had students that were quite distracted, either very, very happy or very sad, in the days following it. Okay. But there was a lot of strong emotion in both directions. Just being aware of, is there anything else going on that they might be like that has happened and that is going to impact your time with them? Knowing that is going to help you have a much more successful class period with them. Okay, then let's do a little bit of, okay, once we know what they need more help with, let's start with the skill part of it. Okay, so let's practice some of the skills, give them, let's remind them of a particular skill, how to do it, and then let's give them some problems. Say, okay, I want you to get with your partner or get with a small group of 3 people or put them at the board, and we're going to do some practice, get a chance to get our brains loosened up and get working on some things. Include student success somehow, have some kind of, and again, do you have to do it in order, not necessarily. You could do like equip, I guess, at a different place. It doesn't, you could probably do that at any place, but trying to get in some kind of student success tip or activity or something in some way, shape, or form that makes sense. It doesn't, I don't want you to do it in a way that feels like, well, this woman from Illinois told us we're supposed to do this every time. Like, I don't know why I'm doing this. No, make it like it should have a point. Okay. So it's going to be different. Like, I'll give you a classic example. First week of the semester, I have my students write down a full schedule of their week, because I always do this my first week of my semester. And I write down all my obligations, all my classes, when I'm going to eat, when I'm going to sleep, my commute. Am I going to actually see my family? Do I want to? You know, little things like that, just life, my job, all of it. Write everything down and have them think about, okay, so now when are you going to study? When are you going to make all this happen? And this is, you know, sometimes it's not great. You'll have people who go, okay, I'm working 40 hours a week. I have 3 kids. I'm taking 16 hours. I don't know how I'm going to make this happen. Okay, well, it's better to know that now, because we may need to adjust your schedule. We may need to adjust your work schedule. And they may be like, I can't, I have to make this amount of money. Okay, then we might need to adjust your class schedule. But better to know that now than have a breakdown at week 4 when all the exams hit. Okay, so you know, that's one thing I would do during week 1. Like I'm talking about right now, week 12 or 13, I'd be asking, have you registered for next semester? It could be whatever. When I'm later in the semester, a tip I always give them is, do you know when your finals are? And do you know like when you have to be at them? And it may not be at your regular class time on your regular class day. It could be totally different. Some schools have a very different final schedule than they do regular schedule, and students assume too much. I would be making sure they knew that. One of the things I would be asking to do is make sure you don't have any finals that conflict. This used to happen at my college. People would just go rogue and they would just have their final exam. They'd be like, I want to be done on Monday. So they would just have all their finals on Monday when some other department was supposed to have a final on Monday. And a student would be like, what am I supposed to do? They're at the same time. Well, we need to deal with that because it's a problem for the student, even though the problem that they didn't cause the problem. But it's like, that would be a tip I would be giving them. Do you know when you're supposed to be, where you're supposed to be? And are there any conflicts with your schedule? Okay, or your work schedule, could be that. Scaffold, we're going to do a bridge problem. I've got an example to come, but it's not just doing the problem, it's also analyzing the problem. How did we think through it? What were we doing as we were solving that problem? Talking about the thought process so they can understand better how to actually go about solving math problems. And the last thing is apply. So this could be actually having them do a college level problem. Okay, it could be something that they're working on right now in the course. It could be like, if it's stats, it might be a hypothesis test. Actually have them do it. But the thing I would emphasize is not you up at the board doing it, but give them a problem, have them do it, have them talk about it, and then verbalize how they actually solved it. The fancy word for this is apply expert thinking. Actually explain, like verbalize, like, what were you thinking? How did you know? Like let's say you're doing a hypothesis test. It's like, how did you know what the null and alternate were? Like, how did you know it was a mean? Like, what told you that? Okay, let's talk about that. Let's talk about what in the problem was the giveaway on that. Not just say, well, you know, this is a hypothesis test and it's about the mean, so we're just going to go write mu equals. It's like, no, stop for a second and just ask, okay, how did I even know that? And then, you know, like, what clued me into it? That thought process is so crucial to them being successful. Okay, so let's get some tips for using this. So number 1 is be willing to be flexible in terms of the proportion of time you spend on each of these components. And not all of you are going to do that template that I showed. And some of you will do something similar, but only parts of it. Like I said, there's no one magic way. This is just an approach that can work. I would love for you to try it and then make it adjusted until it works for you, which could look totally different. And I would love to hear what that is, because that can happen. But be flexible. You cannot be too rigid with this. Okay, it's going to vary how much time you're spending on each of those components each week, each semester, throughout the semester. It's just, that's what's going to happen. Some teachers really love to make a worksheet for each week or each class period, that it gives them a lot of like comfort, because then they know all the components are hit. They'll have a bridge problem on it. They'll have an application. They'll have a couple of skills. They'll have some little tip or some student success activity, but they don't feel like they have to like come up with it all on the fly or try to remember all of it. So if that's you, a worksheet could be a great tool. Now, I'm going to give you a giant tip. Nearly every publisher has come out with co-requisite support, and lots of it. And I will say, and if you have one that you're like, oh no, it is excellent, Kathy, you should look at this, please email me and let me know. But most of them that I've seen are cobbled together things that used to be done in a standalone developmental class, and it's too much content and not enough of the different things that we need for students to be successful. So please don't assume that you can just use publisher content or publisher worksheets. You might, but you might not. So I want you to be aware of that. And this would be a great thing to do as like, if you got a couple people in your department, like get together and be like, okay, could we split the workload a little bit on this? Could someone take the first 3 weeks and I'll take the next 3 weeks? And so we don't all have to feel like we have to make all these like worksheets together. Okay. Some people don't want to have a worksheet though. If that's okay. You might just have a Post-it note with some contingency problems on it. Okay. Like this, number 6 would probably be a good bridge problem. And number 12 is going to be my application problem. Who knows? Whatever makes sense for you. Or maybe you have like a little prompt, or make sure I tell them to sign up for their classes in the spring. Some people, that's what they have. They have a Post-it or however you do it, or a note on their phone. Make it work for your teaching style. The main thing is you don't have to do every single class period exactly the same way. And I would challenge you to have some creativity and do some different things and vary it and not be in a rut. And this is where if you're talking to other people, other faculty, you'll get good ideas. They'll be like, oh, I would have never thought to do that. That's really fun. We could try that for assessing where they're at. Building themed classrooms. I'm going to mention that again. The book, even though it says it's K-12, absolutely applies to higher ed. There is a free Facebook board. Well, the one for K-12 has like 30,000 people on it. The one for higher ed, there's a BTC higher ed board. And it has a couple of thousand people on it, but that's a good board too. If you want to like talk to other people that are teaching the same content you are and trying this approach in the classroom and problem solve with them. So that's, there's all kinds of information about BTC. It's not for everybody. And it's also not magic. Okay. It's a tool. All of these things are tools. I'm too old to think anything's magic anymore. I've been told too many times, this is going to be our magic bullet. And it's like, it doesn't exist. Okay. We pick and choose the things that work and try to incorporate them. Okay. So I want to give you some examples of bridge problems. Now, there is no limit to what you can make into a bridge problem. So I should have had this first. I probably have it on a later slide. The way I'm defining it is a problem that is more than a traditional skill level developmental problem, but it is not quite as difficult as a college level problem. And it is bridging the gap. It is helping students make steps towards college level understanding. Okay. The way that I do that is I try to think, what is really hard about this particular college level problem? Is there something that we could do, just part of it, to help them improve that particular skill? So let me give you an example. So one could be, let's say you're teaching the finance unit in your QR class, your liberal arts math class. And eventually you're going to get to problems like this. I took this straight out of a textbook. Okay. This is so overwhelming to students. A lot of them will be like, why aren't there bullet points? Good God, all the sentences, all the words. My gosh, there's so much. And it's like, there's so many words, there's so many numbers. They don't know where to start. It's just like, what am I supposed to do? I don't even know where to begin. Okay. So one technique you could use is, this is what I call an exploded view. Take the problem and you could put it up on a slide. You put it on PowerPoint. You can put it on a piece of paper, whatever you want to do, but make every sentence its own line and have visible visual space between each line. Now you might be, Kathy, I've done things like that forever. Great. I'm not saying that you haven't done it. What I'm hoping to trigger in people this is like, oh, I already do something like this. And just what I'm hoping for you to understand is there are things that you're probably doing that you could utilize more in a co-requisite class to greater effect than you may realize. Okay. So this technique, and I would give this to them, I would put them in their groups, and I would say, you're going to go through and you're going to read each sentence. You're going to understand the sentence. So don't leave it until you actually know what it says. And then you're going to write down any facts that you can actually use from it. So if they read the first line, they're going to be like, okay, is that 17.99% APR? Like, what is that? And someone's like, I think that's an interest rate. Okay. So does that have something that has a variable? Can I write that? And do I write it as R equals 17.99, or does it have to be something different so I can actually put it in my calculator? Compounding daily. What does that mean? Okay. So here's what I want you to realize. If you do the problem the way I'm explaining, this will take you 20 minutes, every bit of it. This is long. Okay. So the thing I want you to realize is and it's not always going to be like that, but that's okay. Less is more. You don't have to plan 10 bridge problems. Sometimes one will do it. One good problem and have like time to work on it and discuss it. Okay. So that's one example. Let's look at pre-calculus college algebra. Okay. So let's say you're doing the transformations, and I'm not asking them in this problem because let's be real, they'll just go, I'll type it in their calculator. I'm asking them not to graph it. I'm asking them to state the transformations. What is the parent function? And then what do all of those different numbers that are involved, what do they actually do to that parent function? Okay. Some students will think this is easy. So I don't want everybody to think them saying this is like a level 10 problem. It isn't, but there's a lot of students that will think this is hard because there's just a lot going on because they don't necessarily see it the same way we see it. Like I'm looking at that and I'm seeing x cubed. And then I'm thinking, what are all the things that we did to it? They're like, I don't know why you're seeing x cubed. There's an x plus 8 and there's a cubed, but they're not necessarily seeing what we do. So what you can do instead to make it a little bit more approachable is what I call hold constant and separate. Okay. Instead of having all these like stuff that's going on, I picked one parent function in this case, x squared. And then I picked one constant. I picked the number 4. And what I did was I started combining them with different operations, adding, subtracting, parentheses, different things. And so there's less for the brain to try to have to process. It's like every single time, it's only a 4 and it's only an x squared. So it's like, I know I'm a parabola and I know I'm dealing with the number 4. Now all I can do, my brain can just focus on what is happening between that number, what operation, and what impact does it have on the graph. This gives them a chance just to make sense of different transformations. And again, you might be like, I always do something like this. Great. I'm saying, please keep doing that. And if you're like, well, I do that in the regular class, do it again in the co-rack, do a different version with a different problem because it's a good thing to use and it will help them. And then build up and actually have them do a full college level problem. But some things like this help them get there. Okay, here's an example from statistics. So I pulled this straight out of the stats book that I have taught out of many times. So this is a problem again, correlation and regression. Actually from the regression, it's probably, yeah, this is from 4.2 because they're referencing from problem in 4.1, taught the book forever. And they have all these parts to it, which in some ways makes it a little more approachable to students because it's broken into parts, but it's still a lot of words. There's still a lot going on here. They're not going to like this. Okay. The numbers aren't nice. They're like, what's the Y with a little thing above it? Like, what is that about? You know, there's just a lot going on with it. They're not going to think Y hat like we do, but they're going to be like wondering what's going on. Okay. So here's another thing you can do. This is yet another reason. So I want everyone to know whether or not you primarily taught developmental or also taught developmental. I do not want you to think that that skill set doesn't matter. It is so valuable. So this is a problem. It is from our book. Take it and run with it. I'm not asking you to buy the book. Use the problem for free if you want. And if you have my math lab, you can go in and get my book for free, and you can find, my publisher's not on this call, so I can say this. You can go in and get anything you want, and you can get more problems like this. I don't care, use them. But the problems that we did in like QuantWay, StatWay, the New Mathways project, math literacy, lots of them are really good bridge problems. They really are more than the traditional dev ed, but not all the way to college level. There's tons of good stuff there that you can use. In this case, it's similar, but simpler. Okay. And that's more doable to students. It's broken into 3 pretty small paragraphs, actually 3 sentences. And there's some space. It's real, but the numbers are nicer. They're not quite so large. It's just a little bit more accessible. They work on that. And then we can build up to, now let's actually do this in the real context of how does this look like in a stats class? Okay. All right, so bridge problems, bridge the gap. They make things a little bit more doable. They give students an entry point into getting on their way to more complicated content. They can be applied. They do not have to be applied. That's why I showed you the pre-calculus example. It might be something completely just an algebra that's abstract. That is okay. I'm giving you a checklist. So as someone who's written a lot of bridge problems, because we had to write a bunch for our textbook, but I've also just been writing them for years, I put this handout together years ago. I think I put it together during the pandemic and provided it to teachers because they were like, they're just going to Google, they're just going to check, they're just going to photo math. And if you don't know what photo math is, when this is done, go figure that out, because I guarantee you your students do. Okay. But photo math, it's an app. Okay. This is a great way. There's a bunch of techniques here, how to write interesting problems that they can't just put into like photo math to do. Okay, so I'm not going to read all of these to you. I don't want to bore you, but there's a bunch of different techniques. I'm going to give you, we'll look at number 6 because it's my absolute favorite. You give them an equation and you ask them, is it always, sometimes, or never true? Don't say solve, just say, is it always, sometimes, or never true? It will, like your good students will be like, I don't know what you're asking me, because that's what it's trying to get at. Do you actually know what the solution means? Not just what it is, can you find it, but you actually know what that means for this statement. That kind of stuff is just, it's just really good. Now, hopefully you can't just put that in Chat GPT, but who knows, the thing's so dang smart, it probably could just tell you, but that spoils all the fun. So you'll have a link to that. And like I said, I'll put a link into Jess's drive with all of the student success content because she made it publicly available. I'll put that in these, and then Whitney, I'll resend you the link. Less is more. You don't have to write 10 of these. Just pick a couple of them. If you want more of them and you don't feel like writing them, if you ever heard of the Open Middle, it's a book by Robert Kaplinski, but it's also a website. He has a website where he has gobs of really cool problems. And I had a heyday just like picking out a few things so you could actually see them. He's got a bunch that are like this. They are ready to go as Google Slides. The idea is there is something open to it, that it's not a fixed solution. So like in this case, it would be, and there might be a single solution, but there's usually some element of openness to the problem. And he's done a lot of this with middle schoolers. So if you can get a middle schooler to, actually be willing to pay attention and do that, I think that's about as good as you can get. But they're great bridge problems. They will make students stop and think and talk, and they're interesting. Okay. So like in this case, fill in the blanks to find the largest and smallest by finding the largest and smallest integers that will make the quadratic expression factorable. Not just factor this thing, but think about what do I need to have in it, largest and smallest, so that it would be factorable. Much different, much more involved, and more thinking and talking will be involved in it. This is another one I liked. Create a system of 2 equations using digits 1 through 30, at most 1 time each. Fill in the boxes to create a system of 2 linear equations where 3, 2 is the solution to the system. So, it's just kind of nice. It's something a little bit different, and it will get them thinking. And do they really understand what the solution is? Okay. You may have heard of low floor, high ceiling problems. These are problems that have an easy access point that students can, like many students can start working on the problem, but they have ways to extend them. So if you have students that get it very quickly or they're really, really good at math, you can extend it and give them more as well. There's something a little bit for everybody. There's all kinds of ways to make them, but I also have a link to a library that has more questions that you can use to create more low floor, high ceiling problems. But again, that concept, low floor, high ceiling, is in kind of like the bridge concept. There's lots of different ways to satisfy it. You're just trying to have something that has a low barrier to entry, that anybody can start working on it. And it's not like they're going to have to know a bunch of math, but it has some interesting extensions. And you can go further with it for the students who could handle that. Okay, so we are almost done, and I've got a question I'm going to answer from the chat. So if you are going to design a co-requisite class period, here is an activity that you can do to help you do that. So one of the things you could think about is, and you guys could actually do this for, again, if you're teaching a co-requisite next week, you could try this out. And I would encourage you to do that, just experiment a little bit and see what you liked and what you didn't like, and then what you're going to adjust for the next time. So you can pick your course, pick the topic that you're going to have the co-requisite class period for. Okay. The next thing is figure out, okay, how am I going to get some information from them before I start going in all the stuff I'm going to do? Let's first find out what they need. So that's one of the things I was thinking about before this talk. What could I ask them that could help me understand what do they need? And I don't know that I hit the mark on everything. I was really glad that what you guys told me different things you need, because I'm like, oh, we probably needed to talk about this. And there's other things, but I was hoping to hit a variety of things that would be useful. Okay. The next thing is, what skills were involved with this topic that they might need to be taught or retaught, that they need more help with. Okay. The next thing is, what's some kind of student success, either skill, concept, activity that would make sense for the time of the semester that we're in? What could we talk about? What would something that would be applicable and the students would, benefit from that knowledge? Okay. Number 4, how could I bridge the gap from those kinds of problems that I'm doing in number 2 that are more skill level? How could I bridge the gap up to where I'm trying to get to, which is number 5, which is what college level problem I'm going to do? What's in between? Okay, what's something I could do to bridge the gap to college level content? And then what college level problem do I want to work on with them? And how do I want to do that? And I know we're almost, hey, I always like it sometimes when I actually get it right. Look at that. I actually was at time and I had that. But I wanted to answer one that we got. So here's the thing that I want people to understand, because there's a lot of concern especially because the movement that you guys have made in Kansas is what several states have done, which is that standalone developmental is not going to be an option going forward. Okay. Here's the thing I want people to understand, because I work with so many schools and I see this all the time. That does not mean that all of a sudden some people at the college are just no longer needed or no longer valuable. Could not be further from the truth. I want you to know that because what happens is some schools have developmental only departments, and they have people that either that's the only courses they're comfortable teaching or regularly teach. Sometimes that's the only courses they're credentialed to teach. It doesn't mean that those people are not valuable. And I've worked with multiple schools where we've absolutely made sure that those people had load, they were getting to use their talents, but they were using them in a different way that supported co-requisite classes. So I want you to know that sometimes it requires thinking outside the box for your school in terms of what you have available to you, but there's ways to make that work. And it can just be, I was working with a college last week that was in North Dakota. In their situation, they're just going to have their developmental only people are going to be teaching the co-requisites, and their college level people are going to teach the college level content. And so we were talking about how do we do that? We mapped all the courses out together. We planned them. We did everything so that, and then we figured out how often are they going to talk to each other and make sure that they can make this work, because there's 2 different people teaching it. But that's their approach. That's how they're going to do it. And that person has load. They have a fantastic skill set, and they're going to be teaching a variety of different co-recs. And they worked with the faculty at primarily do college level to actually plan that. Okay. All right. So Whitney, can I briefly tell them something about next Friday? I don't know if all of them will be on next Friday, but I wanted to mention this. Is that okay?
Yes. So I would say the vast majority of the people on the call today are not going to be there at the executive implementation team meeting.
That's right.
These are kind of a separate a group of people. So go for it. Yeah.
Okay. So just briefly, what I wanted to mention is I'm just so glad to see Connie is here. I know she's done great work with you guys. I know that you've done a ton of stuff as a state, as a group, working on things. And now there's a lot of schools that are heading into implementation are kind of a little bit nervous, a little bit scared. What is this going to mean for my school? So one of the things is I'm going to be presenting to the EIT group next week. Stephanie Groover's going to be also presenting. She's going to be talking about Dodge City. I'm going to be relaying some different things, some tips that will help the executive leadership, so vice presidents, and it will help them. But I am also going to mention some things that my company can provide if schools in Kansas are looking for some support. I've already worked with multiple colleges in Kansas, and I'm getting ready to work with another one. I'm very familiar with the KBOR, the guidelines and all of it, and how to make it work at a variety of different schools So next week, I'm going to be mentioning some things that are going to be available that they might be interested in. And I'm trying to do them at a couple of different price points. If they're like, we don't have a ton of money, but we would like to have something, we'd like to support our faculty, I'm going to be trying to offer a couple of different things. So I just want you to know, if you're like, ooh, I liked this, I want some more help, I am going to be mentioning some things. I have worked with Pratt and Dodge City in Kansas. So I know they're both small schools, great schools though, love them, I want to tell you that. But I've also worked with much larger schools in another state, but I've worked with large schools as well.
Okay. Are there any last minute questions for our speaker here today?
And actually, here, one thing I want to do is, well, you saw my email, you're going to get the slides. If you have a question, just email me. Now, I'm not saying I'll be quick on it. I'm gonna be the first to tell you that, but I will respond to you. And so email me if there's something you need. Also, if you're on LinkedIn and you want to connect, do that. I love that. So, you know, and if you're at Matic, come by and say hi, because I'm here for 6 more hours.
Thank you so very much for presenting today. There was a wealth of information and I learned a ton of techniques. So I really, really appreciate it. And I know that we all did as well. We don't have very many announcements for today. There's one more faculty professional development opportunity in December. It will be opened up on Monday for registration. Other than that, all right. Thank you guys so much for coming. And again, thank you to our speaker, Kathleen Alme. We really appreciate it.